Hey everyone, I'm Matt Vollmer from Coder, and we deliver a platform that orchestrates enterprise development environments. Today I'm talking about AI coding agents and how to scale them effectively within your enterprise. You've probably seen the hype autonomous agents that promise to turbocharge development. And our perspective here at Coder is that we're not really chasing this trend. In fact, we've been laying the groundwork for it for years. And in our own experiments, agents solved nearly half the engineering tasks we gave them. And that showed us what was possible. It's a new level of developer productivity beyond the one dev, one IDE model. But what we learned is that with great power, of course, comes great risk. And if deployed carelessly, these agents can frustrate developers, they can slow down delivery, they can even break things. So today I'll share what we learned, what works, and what doesn't. Over the past few years, developer productivity inside the IDE has really taken off. So it started having your own IDE, and then came code assistant plugins. And now we've got fully AI assisted IDEs like Cursor that feel almost Copilot like. But the thing is, we're still hitting a ceiling of what one dev, one IDE can do. And we're entering a new chapter now, agentic AI. And this is where one developer doesn't just code faster, they manage a fleet of agents tackling tasks in parallel. And that's the shift from AI assisted development to AI extended development. And that shift is what unlocks the next level of scale. AI coding agents offer a huge productivity boost, especially if especially if you deploy them on tasks that may be considered grunt work, or if you use them to tackle issues in parallel. So it's been a game changer, and one developer managing many agents instead of doing everything solo. But there's a catch. If misused, agents can create more problems than they solve. And we're at this inflection point where adopting AI coding agents the right way will be the difference between accelerating innovation and taking a major step backwards. We've seen poor suggestions when agents tackled issues without context, a flood of PRs when anyone could assign tasks, and it can be a very counterproductive experience for even your best developers. So again, with great power comes great responsibility, and the goal isn't just using agents, it's using them wisely. And this is where I'll walk through how we unlocked the upside potential of AI agents without really drowning in unnecessary chaos. So, to make AI coding agents a help and not a hindrance, we found three things that really mattered. The first is to provide context. Agents need the right info to write good code, and without it, they're blinding code like the rest of us would. Second, we found that we needed to delegate responsibly. So this is especially important in the early days when anyone can be considered a citizen developer. Just because someone can use an agent doesn't mean they should. And we need to control who's assigning tasks to agents and make sure those tasks are appropriate. And third is setting boundaries. So without limits, agents can mess up environments, or run up costs very quickly. So by putting strong guardrails in place, we keep things productive and safe. And we found that these three keys, context, responsibility, and boundaries, are critical, and they're really the basis for this talk. So let's start with the first one, which is context. Because agents can't do quality work if they don't understand the assignment, it's important that we give them as much useful information as possible. Think of them like new hires, right? No docs, no code, no access, no background. They have no chance of success. And we saw this ourselves. Agents without context produced broken code or made things even worse than where we started. And then developers had to waste time fixing those mistakes instead of moving forward. So poor context doesn't just slow the agent, it slows down the team. And the lesson here is that giving agents full context isn't optional, it's really required for productivity. So at Coder, we solve this by giving agents access to real development environments, not just contained sandboxes. Agents can read the actual code base, they can browse docs, they can review tickets, just like a real teammate. And we ran a test with an agent that we deployed in a real development environment, and that agent was Claude Code. And when Claude had full access to the GitHub repo, issue history, internal docs, even backstage IDP via MCP. It crushed the task. It did so well. And it generated a valid patch with minimal tweaks. And that really blew us away. The success that came from context, Claude had everything it needed to understand and solve the issue. So our platform makes this possible by embedding agents into real secure development environments. They can run builds, they can test changes, they can even access internal tools like CI or Backstage. Um, so in short, agents are treated like teammates. And when they're given the same access, their output dramatically improves. And that's when they start genuinely saving developers time instead of costing it. In our trials, the sweet spot was pretty clear. So self-contained, well-defined tasks, and agents are great at small to medium bug fixes, like routine tickets that commonly pile up. They handle minor UI tweaks and visual polish without really breaking a sweat, and they're perfect for those good first GitHub issues. Right, clear scope, low complexity, easy to review. One of our engineers actually described his experience as pairing with a super fast junior dev who could write code at 100 times the speed of a human junior developer. So by assigning these agents these types of jobs, you can protect your team's innovation time. So dev brains stay focused on high value work while the AI handles some of those grunt tasks, if you will. The second key is to delegate responsibly. So, because not everyone should be directing AI agents from the beginning, from the word go, especially in those early days when you're trying to achieve adoption. What we've seen happen is when non technical folks fire off tasks to AI, we ended up with a flood of low quality PRs. They were sloppy and in some cases unreviewable. And our senior devs, they were suddenly left in this position where they're not building, but they're playing cleanup crew, right? They're reviewing half baked code instead of shipping features, and that's not just inefficient; it really tanks morale and slows your entire team down. So the big takeaway here is who delegates and how they delegate really makes the difference, especially as you're trying to build that grassroots adoption in the early days. We have to be intentional about who's allowed to assign tasks and what kinds of tasks agents take on. So, what should we do instead? Well, by starting to treat AI agents like a teammate, not just throwaway tools, this means that we're putting our most experienced devs in charge and not just directing the agents, right? Um, these are folks who understand code quality and can craft solid prompts. They can stick to their normal dev flow. They can assign GitHub issues, review PRs, leave comments, and always have a human review before you merge. No exceptions, especially in the early days. Yes, there are agents out there that are specifically designed to handle code review, but most of us wouldn't hand the keys to the kingdom to a first year developer on day one. So nothing from the agent should go straight to production without eyes on it. We also track who initiated every agent task. So there's accountability. And the result is the agent becomes an extension of our development team, not just this rogue contributor. And this helps to keep quality high, teams in control, and agents genuinely helpful. And this is a visual of a model we want to avoid if we're serious about scaling developer productivity, right? We don't want a world where anyone with an internet access, internet connection can flood your most valuable engineers with sketchy PRs. That kind of open access chaos can really slow teams down and break trust. So key three here is boundaries, because agents need guardrails to stay helpful, not harmful. So without limits, an agent can break environments, and they can certainly blow up the AI token usage if left uncontained. And in one of our early tests, an agent completely changed the config file and totally bricked a developer's workspace. And if this wasn't happening in an ephemeral workspace, the developer would have lost, probably a full day recovering their development environment, right? That can't happen at scale. Now imagine that same agent looping in compute heavy tasks, or worse, leaking credentials. So the risk compounds fast when you have dozens or hundreds of agents in play. And you shouldn't let the agents run loose on laptops and hope for the best, right? We need a safer, more controlled approach. So at Coder, we run the agents inside ephemeral isolated environments. Each agent effectively gets its own disposable bin on a VM or a container. It spins up, does the work, then shuts down, clean slate every time. We use infrastructure as code to create those environments at scale, so that happens quickly and hundreds at a time if necessary. And every one of them has guardrails, right? So we apply strict access controls, so agents can only touch what they need. We log everything the agent does, so there's always an audit trail. We can even cap usage, memory, API calls, spend, so nothing gets out of hand. And if something goes wrong, with one click, the workspace is gone and can be re-provisioned from scratch quickly and easily. And that gives us the confidence to scale agents safely with little to no risk of real systems or budgets. We can let human and an AI agent occupy the same workspace, but with different permissions. So it's a lot like peer programming, but one partner has admin rights and the other is on a short leash. And in Coder, the human might have full access to the repo, network, and file system, but the AI agent is totally fenced in, restricted to just what it needs. We can limit to a specific repo, a subset of files, or even approved external services that you already manage. Um, it can't run destructive commands or reach outside URLs. So, for example, the agent might read code but can't modify critical files unless it's via a PR. Or it might fetch packages from your registry but not hit random endpoints. So you end up with two clear boundaries inside one environment, one for the human, one for AI. And AI can't nuke the workspace. It doesn't have permission. And the human is still in full control, watching everything in real time. And this kind of setup really gives you the best of both worlds, right? You get that collaboration, but you also get it without compromise. And it's one more layer of protection that makes AI agents useful, not dangerous. So, to bring this full circle, AI agents certainly can unlock real productivity gains, but only if we deploy them safely and wisely, especially in those early days when grassroots adoption by your development teams can be make or break. So that means we give them the context they need to understand the task at hand. We delegate access to these agents responsibly so the right people are in charge. And we set boundaries to keep things more secure and under control. And when we nailed those three, we found that the agents go from risky to really game changing. And this isn't about replacing developers. It's about AI and developers coming together. There's always going to be more work than a team of developers and their agents can do together. So picture your top engineers supported by these tireless AI assistants who are maybe even coding around the clock and all within guardrails. And that's the future, right? Safer, faster, more creative software development. And we're already here helping teams make that a real future. Human and AI devs building side by side, each doing what they do best. So thanks for tuning in. Hopefully there are a few nuggets here that'll help you be more effective and efficient in exploring AI coding agents in your organization. And if you have any questions, let us know. We're happy to share more about how we deploy agents at scale and what we're learning.